Welcome back to another Sunrise 2.x tutorial video. Today's topic of discussion will be on position and torque referencing. So let's start off by first discussing what is position referencing, when can position referencing be performed, and what is the criteria for position referencing. So position referencing is a motion sequence that allows us to check the mastering of the position sensors within the kinematic system by determining if the measured position of an axis corresponds to the actual mechanical position of that axis. Position referencing typically is carried out through a sunrise application through means of basic motion. However, it can also be triggered by means of just jogging the robot with the smart pad, or even through a simple hand guiding session. The criteria for position referencing is that each axis must rotate over its respective mechanical zero position with a speed of less than 20 degrees per second. Note that the direction in which it rotates does not matter. However, it must rotate through a defined axis-specific range. And this axis-specific range varies based on the robot model and which axis you are rotating. So now that we have a brief understanding of position referencing, let's go ahead and talk about what torque referencing is, when can I torque reference on the robot, and what is the criteria for torque referencing. So during torque referencing, the mastering of the axis torque sensors within the kinematic system is checked by the safety controller. The safety controller checks if the expected torque of an axis corresponds to the actual torque of that axis. Torque referencing is considered successful if the difference in axis torque for each axis lies within a defined tolerance. Torque referencing must be executed via a torque referencing application. This is because we will be sending Sunrise service requests to request the safety controller to take torque referencing measurements. So now let's go ahead and discuss some different criteria to accomplish a successful torque referencing. First, we need to make sure that the configured robot mounting orientation located in the stationsetup.cat accurately depicts the real robot mounting orientation. Second, if a tool is attached to the robot during torque referencing, the tool must be taught correctly, have accurate load data recorded, and be safety rated in the safety configurations file. In regards to the actual torque referencing, the robot must be at a standstill during the torque referencing measurements taken by the safety controller. The robot must also be at a standstill between its last motion and the starting measurement of the safety controller for a minimum of 2.5 seconds. This is to mitigate any micro oscillations in the sensor readings by letting the robot find its settling point. The maximum time allowed between measurements is 15 seconds. This is a hard criteria to meet because the robot must move from pose A to pose B, move positive or negative offset, then return to pose B, and wait the 2.5 seconds before sending the Sunrise service request to the safety controller to take the torque measurement. And finally, the robot must have 5 main poses, all which consist of a positive and negative measurement at each pose. In regards to recommendations for torque referencing, it's good to start off by just modifying the torque referencing measurement positions such that they represent the edges of the utilized workspace for your application. This will provide a more accurate representation of the torques that the robot can encounter during the application. It's to your benefit that you do not perform torque referencing in the same pose for all 5 measurements. Although the robot will successfully torque reference this way, it will not be an accurate representation of the torques encountered in the utilized workspace for your application. So now that we have a basic understanding of what position referencing is and torque referencing is, let's go ahead and jump into Sunrise and walk through a position and torque referencing example. So to start off, we can right-click on our com.tutorial.examples package, go to New Sunrise Application, click on our example from template folder and click on the robot that we're using and select the position and joint torque sensor referencing application. Note that if this application is not available to you, I have a link in the description where you can pull the code from our GitHub gist. Go ahead and click finish and you will see the position and torque referencing application. So now let's just walk through the position and torque referencing example application. The first thing I would like to point out is that from line 77 to 81, these are the positions in which you will be torque referencing at. For the purpose of this example application, leave these positions as they are so that you can see what a successful torque and position referencing looks like. However, in your real application, you should adjust these to the edges of your utilized workspace so that this will provide a more accurate representation of the torques that your robot can encounter during the application. So for each one of these poses, we'll have a positive and negative torque measurement taken, and then from pose say A to pose B and then pose B to pose C, we'll be slowly knocking off our position referencing as our joints rotate through the specific axis ranges. So now let's just briefly discuss how torque referencing actually looks like in the application. Remember that at each one of these 5 nominal poses, we're doing some negative offset and then taking a measurement, and then some positive offset and then taking a measurement. And remember that between each of these measurements, we cannot exceed the 15-second maximum timeout. So let's walk through all the things that have to happen within that 15 seconds. So say we've taken our last measurement after this position here, and we're now moving to the next position we're going to take some offset measurement at. So we've just taken our last measurement here, we jump into line 78, and we pass in some pose to our measure on position method. Our measure on position method moves the robot to that parameter position, then applies some motion offset. So we offset all of the axes by some amount. Then we move back to the initial position, the initial nominal position, and we go ahead and trigger this measurement. Now the trigger measurement, remember, we have to wait 2.5 seconds to reduce the robot vibration. Once the robot vibration ceases, we go ahead and create our sunrise service request command for joint torque referencing, and we can go ahead and execute the sunrise service request. At this point, we have effectively ended our 15-second interval, and we are now creating this next 15-second interval in which we now, after we trigger the measurement, we go ahead and do our next other direction offset, go back to our nominal position, and trigger the next measurement. And with that last piece of information, this will now conclude our sunrise tutorial on position referencing and torque referencing.